Hi, this is a presentation of wireless LAN operations, and it is a part of my CCNA3 course. In this chapter, we will look at how the wireless communication actually works. When we look into the 802.11 frame, which is the frame on the layer 2 in wireless communication, we will see that the general is that we have a header and the payload and some kind of check in the end. If you look at the header, it actually has a lot of different fields. We have something, a frame control, we have duration, we have address 1, 2, which is typically the MAC address of the sender and the receiver, and the address 3 could be, for instance, the default gateway, sometimes the MAC address of that. We have a sequence control, we have an address 4, which when we have ad hoc networks, where we have 2 computers that communicate without an access point, then we might need the 4th address as well. And within these fields, we can see the content. And if we, for instance, go into Wireshark and listens on the wireless network, we will also see a lot of these frames going back and forth. And we can go in and see the sub-fields, for instance, within the controlled field. So we will see the actual contents when we listen in. And when we are using, for instance, Wireshark on a wireless network, it's quite easy to listen in because we don't need a cable. It's much easier to eavesdrop on a wireless network than it is on a cable network. And by just looking into these header fields, there are a lot of information that we can use for that purpose if you want, for instance, to try to break into a wireless network. If you go into the control frame or the control field, we will see here that there are a lot of subfields again, where we will have, for instance, what kind of a type it is, the protocol version, which version that we are using, and there are, if this is a retry packet, how power management, security, and there are some reserved ones as well. So a lot of information in these fields. For instance, the frame subtype is whether this is an association request or response, or is it a reassociation request or response, a probe request or response, a beacon frame, a disassociation authentication, or de-authentication frame. And so this, we can see what kind of a frame this is, and we will see a little bit more about the different purposes. And also the frame subtype here is if this is a request to send or clear to send or an acknowledgement. When we are using wireless network, we are using CSMA/CA. We remember from when we looked at the Ethernet protocol, we used almost the same, but a CD in the end, collision detection. Here it is collision avoidance. So we are trying all the time to avoid collisioning to happen. So what we need is that we need to receive a CTS or clear to send from the access point. And when we have that, then we are able to send something. Otherwise, we have to just wait and then try to send once more. So the CSMA-CA algorithm make sure that we don't send and receive at the same time, or we can send and receive at the same time, but we're not sending at the exact same time as others in the wireless network. So what happens when we have a sender and an access point, which is in this case the receiver, is that we first find out whether that there is an access point by sending a discovery. And then when we have discovered and we know the SSID of the access point, then we try to authenticate ourselves, and then we make an association. And when we have the association, then we are able to start sending data. The parameters in the association is, for instance, the SSID, which tells us the name of the wireless network. We have the password, if that is required. Sometimes we also use some kind of a shared key for that. The network mode, which refers to the different standards. Security mode, if we are using WEP or WPA or WPA2, the channel settings that tells us which wireless channel that we want to operate on. When we're looking at discovering the access points, there are two different ways. We have an active mode and a passive mode. The passive mode actually refers to us as clients, which means that we don't have to do anything actively because the access point is sending out their SSID all the time and advertising themselves on the wireless network. So these beacons that are sent out, for instance, tells us the SSID, but also which standard it supports and what kind of security settings it has. If we don't do that, well, then the clients are in an active mode, which means that we need to know the SSID, and then we will send it by indicating that this is this SSID that we want to connect to. And then they try to figure out also, for instance, of the channels and what kind of a standard that we are using. Sorry. Yeah. So what happens here is that when a sender starts or wants to send something, we open up with the authentication, where the client says, authenticate me, and the AP responds back, yes. And if there is a shared key, we will send that along. If it's a shared key authentication, well, then we will look at the key and then we will see that that everything is okay. It's either successful or unsuccessful, of course, depending on the key. Yeah, and then we do the association after that. When we look at how physically the wireless networks is working, well, then we will see that there are different frequency methods, or how they operate on the different frequency. There is something called direct sequence spread spectrum, which is used by 802.11b standard. Yeah, so it spreads the signal over a larger frequency, and therefore makes it more resistant to interference. When we are looking at another way of simulation is the frequency hopping spread spectrum. Here, instead of just operating on one channel, we operate on different channels and also therefore use the channels more efficiently. This is used by the original 802.11 standard. And then we have the one that we are using today, which is the orthogonal frequency division multiplexing, where we multiplex in a single channel and uses multiple subchannels on adjacent frequencies. So this way of emulating or moduling the data on the wireless networks is used by 802.11a, G, and AC. And when we look at the different frequencies that we are using, we can see that the 2.4 gigahertz band is in the ultra-high frequency, whereas if we are using the 5 gigahertz WLANs, it's in the it's in the super high frequency. And if we are using the AD standard, we are in the extremely high frequency area of the microwave area of the radio waves. Yeah, in the electromagnetic spectrum. 802.11b had different channels, and it is important that when we have two different access points and they are neighbors and they interfere in each other's, then we cannot use overlapping or non-overlapping channels. We cannot use overlapping. We need to have these channels that does not overlap each other, and that is channel 1, 6, and 11. In the US, we have 11 standards for the 802.11b, whereas in Europe we actually have 13. But we need to be aware of which channels that we are using. In the other, this is only for 802.11b. This is not so important in the other standards. So if we look at 802.11g or N, we will see that it uses a larger, it uses different bands in the 5 gigahertz band. This is not a crowded frequency as the 2.4 gigahertz is, because 2.4 is the free area where we also have a lot of other wireless devices. Yeah. So we are using typically 2 different channels that we combine. So we have a 40 megahertz channel instead of 2 20 megahertz channels. Of course, when we are planning our wireless LAN, we need to, make sure that we cover all the areas in the buildings. So normally, you make a coverage map of your building, and then you know where to place the different access points. Normally, it's a good idea to place them up high and vertically in the ceiling, where they will send out their information downwards with the antenna, depending on, of course, also how your antenna is. If you have an directional antenna, then you need to take that into consideration as well. Yeah, and that was it. Thank you.